Okay, so we are introducing a new chapter. Some of it's going to seem a little bit familiar and some of it's not. So we've learned how to graph equations in slope-intercept form. We are doing that exact same thing, but we're talking about systems of equations. And a system of equation is two or more linear equations. And when I mean linear equations, I mean in the form y equals mx plus b. So we have to always make sure it's in slope-intercept form. The solution of the system of, or the solution to a system of equations is the point of intersection. In other words, where our graphs are going to cross, where our lines are going to intersect or cross. So we have three types of solutions. The first being where it intersects one time, okay, so that's a one solution problem. Then we have some where you're going to see parallel lines. This means no solution or empty set. And then we have our third type, which if you look at here, it looks like it's only one line, but it's actually two lines, but they're identical, which means they overlap. So we refer to this as infinite, or if you remember the infinity symbol, or also all reals, okay? So as I'm going through this, the first thing and most importantly is making sure our graphs are in slope-intercept form. That means y equals mx plus b. So if they give it to you in standard form, we need to convert it to slope-intercept by solving for y. So let's start out easy. Both of my first examples are already in slope-intercept form. So we're just going to refresh our memory on how to graph. So if I graph number 1 first, okay, this means we start with the y-intercept. So the y-intercept of the first one is -8. So I go down 8 on the y-axis. And then to find the rest of the points, I'm going to follow my slope. My slope here is 1. And again, we have to remember that slope is rise over run. So we're going to do 1 over 1. And the 1 over 1 gives me the directions to get my other points. So I go up 1, right 1. Up 1, right 1, up 1, right 1, up 1, right 1. And it's really important that we're accurate, because if we do not graph accurately, then our equations will not intersect, which means we will not get our the correct answer. So there's the first line. So I went up 1, right 1, up 1, right 1, and then down 1, left 1, down 1, left 1 to finish my line. Then I want to graph the second line. So we're going to start with our y-intercept, which is +1 on the y-axis. My slope here is -2. We're going to make a fraction by putting it over 1. -2 over 1 is down to right 1 from starting at +1. So down to right 1, down to right 1, down to right 1. And if you notice, as I was graphing, I came across a similar point that was also on the other line. This is our point of intersection, so we're going to keep this in mind. But I'm going to continue down 1, right 1, down 1, right 1. To go off, I go up 2, left 1, up 2, left 1 in the opposite direction to finish my line. So yes, you still have to finish it. Now we focus on the point of intersection, and here, so this would be a 1 solution. And where is this point of intersection? We need to give it as an ordered pair. So this coordinate right here would be +3, -5. And there's my answer, okay? So let's do it again, because that was our first one. We got to ease into this. So again, these are already in slope-intercept form. They won't always be that way, so take it when you can. We're going to first start this first one off with +9, the y-intercept of +9. And then my slope gives me the rest, so 1 over 2 is already in rise over run, so we're going to go up 1, right 2, up 1, right 2, but notice it doesn't take me any further. So I have to go the opposite direction, which is down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Then I connect my dots. Now we're going to graph the second equation by starting at +6 on the y-axis. This time my slope is -1. To make it rise over run, we're going to do -1 over 1. Negative over 1 negative 1 over 1 is down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, all the way. Okay, oops. And then continue the opposite direction and go up 1, left 1, up 1, left 1. Notice I overlapped at this point right here, so we're going to keep that in mind as I finish. And we're going to draw a line. So this point of intersection, so this is also a one solution. This intersection point is negative 2, because I went left 2, then up 1, 2, 3, 4, 5, 6, 7, 8. So this point of intersection is negative 2, 8. Okay, so we're going to continue this, but notice these examples, not all of them are slope and intercept form. So if I look at number 3, notice both are in standard form, so I have to convert both to slope-intercept form. So we're going to convert this first one first. Negative 3x plus y equals 8. Solve for y by adding 3x. So y equals, the x goes first, so 3x plus 8. And then the second one, I'm going to convert. Negative x plus y equals negative 2. I'm going to add x to both sides, so y equals x minus 2. Okay, then we're going to graph both. So if I look at the first one, I'm going to start at positive 8. Okay, and I'm going to do my slope, which is 3 over 1, so that's up 1, right 3. Sorry, up 3, right 1. But I can't go up 3, right 1, so I have to go down 3, left 1, 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 okay, to make my line. Then on the second graph, I'm going to start at negative 2 on the y-axis. And this is 1 over 1, so I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, until I run out. And then the opposite direction is down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. This point right here is where they intersect because they overlap on those points. So then I graph. This point of intersection is left 1, 2, 3, 4, negative 5 and 1, 2, 3, 4, 5, negative 7. That point of intersection is negative 5, negative 7. Number 4, one of them is already in slope-intercept form, so we only need to convert this first one. X plus 2y equals 4. So I'm going to subtract x first. Negative x plus 4, divide by 2 to everything. So y equals negative 1/2 x plus 2. Now that I have it in slope-intercept form, okay, we're going to graph the first one. So this one was our first one. We're going to start at positive 2 on the y-axis. And then I'm going to go down 1, right 2, 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 up 1, left 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 2. Okay. And then I look at the other equation and it's exactly the same, which means it's the exact same line, which means if we look at our 3 types, they are identical, which means they overlap. So my answer for this one is infinite. And even if you could have seen that to begin with, you still have to graph the 1, okay? Or all reals or infinite, so which the infinity symbol. Okay, number 5. So y equals a setup for that the second one, so we need to convert this first one. X plus 3y equals negative 15. I'm going to subtract x, so 3y equals negative x minus 15. I'm going to divide by 3 to everything, so y equals negative 1/3 x minus 5. My y, so I'm going to start by graphing this one. My y-intercept is negative 5. My slope is down 1, right 3, down 1, right 3, down 1, right 3. Opposite direction is up 1, left 3, up 1, left 3, up 1, left 3. Okay. Now, this equation, this is one of those special cases, y equals negative 7. So this means it crosses the y-axis at negative 7. Okay, oh, negative 7, sorry, down 7. Okay, and it's a horizontal line, okay, because it has a slope of 0. So this would go across. And the point of intersection is right there. And that intersection point is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6, negative 7 is my point of intersection. Number 6, the first one is already in slope-intercept form, so all I have to do is convert the second one. So I'm going to first subtract x, negative y equals negative x plus 2. Divide everything by negative 1. So y equals negative 1 over negative 1 is positive 1x. Positive 2 over negative 1 is negative 2. So I'm first going to start by graphing the first equation where it starts at positive 5. And then I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1, continued, and then graph. Then the other equation starts at negative 2, but it has the same exact slope as the other line. So can you already predict what kind of equation or what kind of solution this one is going to have? Because I'm going up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1. And if you notice, our lines are parallel because they have the same slope, different y-intercept. And that type of solution is no solution because they're parallel lines. So I could just do a symbol with a not through line through it, or no solution. Oh my goodness. It's not. Okay. Number 7, they are both in standard form, so I need to convert both of them to slope-intercept form. So I'm going to start with the first one. By subtracting 3x to both sides, negative 5y equals negative 3x minus 35. Divide by negative 5. So y equals negative 3 over negative 5 is positive 3 over 5x. Negative 35 divided by negative 5 is positive 7. The second equation, okay, I'm going to subtract 2x to both sides, so y equals negative 2x minus 6. If I start with my first equation, we start at positive 7, and my slope is up 3, right 5, down 3, left 5, down 3, left 5, okay. On the second equation, my graph starts at negative 6. And I'm going to go down to right 1, down to right 1, or up to left 1, up to left 1, up to left 1, up to left 1, up to left 1. And that point where they overlap is the same. That's our intersection point. And we have to identify this point. And this is negative 1, 2, 3, 4, negative 5, positive 4. Is my point of intersection. Last one, number 8. So we're first going to convert this standard form to slope-intercept. So I'm going to subtract 3x to both sides. Negative 2y equals negative 3x minus 18. Then I'm going to divide by negative 2. So y equals negative 3x over negative 2 is 3 over 2x. Negative 18 divided by negative 2 is positive 9. Now, to graph x equals negative 2, that means it's going to cross the x-axis at negative 2, and it's going to be a vertical line going up and down. That's our special case. The other one is going to start at positive 9, and then my slope is up 3, right 2, or down 3, left 2. And there's where they cross, but I got to keep going. Down 3, left 2, down 3, left 2, down 3, left 2, down 3, left 2. Okay, so this point of intersection right there is left 2, so negative 2, up 1, 2, 3, 4, 5, 6. Negative 2, positive 6 is the point of intersection.